Hello everyone, welcome back to my channel Maths with Smart Tip. Today in this video we are solving the questions of complex analysis of GATE 2022 mathematics, and more videos like complete solution of numerical analysis and many other questions of GATE 2022 are already solved in the channel. So go to the playlist GATE 2022 mathematics and check the more videos of GATE 2022. So let's get to solve these questions, and before starting the solution I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. So question number 13 says that consider the function of two real variables given by uxy equal to this function and vxy be the harmonic conjugate of uxy such that v00 equal to 2. Let z equal to x plus iy and fz equal to uxy plus iota vxy, then the value of 4 plus 2 pi f of I pi is. We apply Milne Thompson method directly to solve this question. So first, given that uxy this is equal to e to the power 2x sin 3x cos 2y cos hyperbolic 3y minus cos 3x sin 2y and sin hyperbolic 3y this. Now first we find the value of u00. This is equal to e to the power 0 and this sin x, that means this term is 0, and cos 3x sin 3y. So 0 means they are also sin y, so this is equal to completely 0, so this is equal to 0. Now the Milne Thompson method is given by f equal to integration phi 1 z0 minus I phi 2 z0 dz plus constant. Let us take this constant as f00, which is integrating constant, and phi 1 z0, this means here u is given, so del u del x at z0, and phi 2 z0, this is equal to del u del y at z0. Now we have to find del u del x and del u del y from the given u. So del u del x, this is equal to e power 2x into, first take the y term as constant, so this is equal to cos 2y cos hyperbolic 3y into this e power 2x into sin 3x, so 2 e to the power 2x into sin 3x plus e to the power 2x into 3 sin 3x, this minus take the y term as constant sin 2y and sin hyperbolic 3y into e to the power 2x into cos 3x, so 2 e to the power 2x cos 3x minus e to the power 2x into 3 sin and 3x, this term, and this is cos 3x sin 3x cos 3x, this term. Now del u del y del u del x at the point z0, this is equal, that means x equal to z and y equal to 0, this gives cos 0 1 cos hyperbolic 0 also 1, so 1 into e to the power 2x, so e to the power 2z into sin 3z plus e to the power 3 e to the power 2z cos 3z, this term, and minus sin 2y, this means sin terms 0, so this is equal to 0. So this is equal to clearly 2 e to the power 2z sin, this is very calculative question, 3z plus 3 e to the power 2z cos 3z, this, and now so this is equal to our phi 1 z0. Now phi to z0 equal to, so first we find del u del y. So del u del y equal to, from here I write this del u del y, this is equal to e to the power 2x into sine 3x to minus 2 sine 2y cos hyperbolic 3y plus 3 cos 2y and sine, you check this calculation 2 independently, 3 sine hyperbolic 3y this minus e power 2x cos 3x into 2 cos 2y sine hyperbolic 3y plus 3 sine 2y cos hyperbolic 3y. We check these calculations once again, and phi to z0, this is equal to del u del y at the point z0, that is x equal to z and y equal to 0. If we put x equal to z and y equal to 0, then this gives totally 0. Since these terms are cancelled out, you can check this once again. So this is equal to 0. Now therefore we have to calculate fz. This is equal to integration over phi 1 z0. For phi 1 z0 means e to the power 2 e to the power 2z sine 3z, this term 2 e to the power 2z sine 3z plus 3 e to the power 2z cos of 3z, this term into dz. Now we calculate the value of f00, which is, we take the integrating constant. Now the value of, so and we get u00 equal to 0, and therefore f at 0 this is equal to u plus iv, that is u00 plus iota v00. Now u00 equal to 0, so this is equal to 0 plus, and it is given that v00 equal to 2, so 2 iota. This implies f at 0 this is equal to 2 iota. So let us take this as integrating constant. So plus 2 iota, this is the constant. Now we apply here the formula of class 12, which is integration. Let us write this formula. So this is equal to integration e to the power ax cos bx dx. This formula is equal to e to the power ax by a square plus b square and a cos bx plus b sin bx, this formula, and integration e to the power ax sin bx dx. This is equal to e to the power ax by a square plus b square and a sin bx minus b cos bx. We apply these two formula here. So this is equal to, so fz, this is equal to 2 outside the integration e to the power 2z sin 3z, and we apply this formula. So 2 into e to the power 2z by a square plus b square means 2 square plus 3 square into we have a cos bx, so 2 sin 3x minus 3 cos 3x, this term, and plus 3 into e to the power 2z by 2 square plus 3 square into e to the power 2z cos 3z. We apply this first formula, which is equal to a cos bx means 2 cos 3x plus 3 sin 3x. This is plus 2 iota. This we get. Now this is equal to e to the power 2z by 2 square plus 3 square means 13. Also this is common from these two terms, so this is equal to 2 to the 4 sin 3x minus 6 cos 3x plus 3 to the 6 cos 3x plus 9 sin 3x. So cos 6x, 6 cos 6x cancel. This is equal and plus, sorry, this is z. Sorry, these all are z. These all are z. Z and z. Sorry, these are all z. These are all z. This plus 2i this. So this is equal to 4 plus 9 13. So e to the power 2z into 13 cancel sin z plus 2i. So this is the value of fz. This is a great calculation, but the marks is 1 for these questions. So now we have to find the value 4 pi plus 2 pi f I pi. Now first we find f of I pi. So f of I pi, this is equal to e power 2 I pi sin 3 I pi plus 2i. Now e to the power 2 I pi means cos 2 pi plus I sin 2 pi. I sin 2 pi into sin I pi. This means now sin iz or ix is equal to, we know that I sin hyperbolic z. So we write it as I sin hyperbolic 3 pi plus 2i. So cos 2 pi means 1 and sin 2 pi means 0. So this gives simply I sin 3 pi plus 2i. Now we multiply f I pi by 2i. So 2i f I pi, this is equal to 2i square sin 3 pi, sorry, sin hyperbolic 3 pi plus 4i square. So this is equal to 2i square means minus 2 sin hyperbolic 3 pi minus 4. Now we have to plus 4 again. So 4 plus this term. So now is equal to 4 plus 2i f I pi. This is equal to 4 minus 2 sin hyperbolic I sin. This is I sin. Oh sorry, 2i square means 1. So this is equal to this I sin hyperbolic 3 pi minus 4. 4 cancel. Minus 2 sin hyperbolic 3 pi means e power 3 pi minus e power minus 3 pi by 2. So 2 cancel and this gives e to the power minus 3 pi minus e to the power 3 pi. So this is the answer for this question. The question is simply a 1 marks question, but the calculation is very big. So this is the answer. So which option? The answer is e to the power minus 3 pi plus e to the power minus e to the power 3 pi, option C. Now go to the next question. The question number this we also from GATE 2022. The question says that the value of the integral this integration c z 100 by z power 101 plus 1 dz. Here we apply the theorem which is called argument principle. So which is equal to integration over c f dash z by fz dz. This is equal to 2 pi I into, we know that, n minus p. N is the number of zeros of fz and p is the number of poles of fz. Now the circle is radius at 2 at origin. Now there is, so fz equal to, we have z power 101 plus 1, which is a clearly polynomial, therefore there is no pole, therefore p equal to 0. Now we have to find the number of zeros. Now first we manage this to multiply both sides by 101. So integration z power 100 by z power 101 plus 1, this is equal to 101 z power 100. So if we take fz equal to this, then this is the derivative of fz. So this by f to the power 101 plus 1 and 1 by 101 into dz. Now we apply the argument principle to this integration. So this is equal to 101 into 2 pi I into n minus p. This is the value of the integration. N minus p means 0 here, since there is no poles. So now 101, we have to calculate the number of zeros of fz equal to 0. That means z power 101 plus 1 equal to 0. This implies z power 101 equal to minus 1. This. Now here we apply the concept, that is, if we calculate the number of solutions of z to the power n equal to 1, this means what? This means the function this has n zeros in the circle which is at origin and the radius is modulus of this function. Since if we take z power n equal to alpha, suppose we have to find the nth root of this, then this means we have to find the root which is the circle. The roots of this function belongs to the circle which the center is at origin, and this alpha is a complex number. The roots and the radius is root under mod of alpha, this. So the number of roots from this, the number of roots is clearly 101. Therefore the number of zeros for these functions n equal to 101. And since here it is also noted that this modulus of this is equal to clearly 1, modulus of this. Therefore the roots of the function this are belongs to the origin, the circle of radius 1 and center at origin, this. And in the question it is given that the center, the circle of radius 2 and center of origin, which mod z equal to 1 means this already covered. So the function has zeros in this circle, therefore which is the subset of the given circle. Therefore the total number of zeros are 101. So the integration is equal to 1 by 101 into 2 pi I into n means 101. This is equal to simply 2 pi I, this. So if you any doubt about this question, then please comment me in the comment section below. So this is the correct answer for this problem. Go to the next question. This is a NAT type question. Thing that in this year GATE 2022 there is 2 MCQ, 2 NAT type question, that is numerical answer type, and 1 MSQ. Total 5 questions comes in this year, that is GATE 2022. The radius of convergence. Here the concept is, if R is the radius of convergence of the series z power n, then you know that the radius of convergence of the series summation an z power kn is this r power 1 by k. So here k is given 2. Now so here an equal to 3 to the power n plus 1. Therefore we apply ratio test. So 1 by r, we know that 1 by r equal to limit n tends to infinity n plus 1 by n. So this is equal to limit n tends to infinity n plus 1 means 3 power n plus 2 by 3 power n plus 1. This is equal to limit n tends to infinity simple 3, and this is equal to 3. This implies r equal to 1 by 3, this. Therefore, here the power of z is 2n. Therefore, the radius of convergence is the ROC of the series summation 3 power n plus 1 and z to the power 2n is r power half, that is equal to 1 by root under 3, which is equal to 0.577 something, and in the question the answer should be round up to 2 decimal places, which is equal to 0.58 this. So the radius of convergence of the given series is 0.58. This is the correct answer for this problem. Now the next question says that the number of zeros of the polynomial 2z power 7 and minus 7z power 5 plus 2z cube minus z plus 1 in the unit disk this. This is clearly based on Rouche's theorem. The Rouche's theorem says that, what is Rouche's theorem? The Rouche's theorem says that if fz and zz are analytic inside and on a simple closed curve C and mod of fz is greater than mod of gz on C, that is on the boundary, then fz and fz plus gz have same number of zeros. This is the Rouche's theorem. Now in this case we select fz as the numerically largest coefficient and middle power of z. So we choose here fz equal to, let us take another color. We choose here fz equal to minus 7z to the power 5, highest numerical coefficient and middle power of z, and zz equal to the remaining polynomial 2z power 7 plus 2z cube minus z plus 1. Now the unit disk is mod z equal to less than 1. So C is mod z less than 1. The boundary is mod z equal to 1. Now at the boundary mod of fz equal to, so fz equal to minus 7z to the power 5. So at the boundary mod of fz we put the value of z equal to 1, so minus 7 into 1, this is equal to 7, and mod of gz at the boundary this is equal to 2z to the power 7. So 2z to the power 7 means 2 plus 2 plus 2 plus 1 plus 1, 2 plus 2 plus 1 plus 1, this is equal to 6. Clearly mod of fz is greater than mod of gz at the boundary. So this means fz and fz plus gz had same number, have same number of 0. Now the fz equal to, we get minus 7z to the power 5. The zeros of fz are minus 7 z power 5, this is equal to 0. This means z equal to 0 0 0 0 0 0 of order 5. That means the number of zeros are 5 of fz and fz plus gz. Therefore the number of zeros are clearly 5. This is the answer for this problem. Now go to the next question and last question. This is a great question with big calculation. The question says that let T be a Mobius transformation such that T0 equal to alpha, T alpha equal to 0 and T of T of infinity equal to minus alpha, where alpha equal to minus 1 plus I by root 2. Let L denote the straight line passing through the origin with slope minus 1 and C denote the circle of unit radius centered at origin. Which of the following statements are true? This question is from MSQ type. that is more than one options are correct. Now first we find the transformation. So we know that the cross ratio is preserved for a Mobius transformation or bilinear transformation, you can say. So let the bilinear transformation is from W to Z to W, and then we can write W. Here 3 points are given, so W, W1, W2, W3. This is equal to by cross ratio of W equal to cross ratio of Z plane and W plane, Z1, Z2 and Z3. Now Z1, Z2, Z3 means here it is 0, alpha and infinity, and fourth we take Z, and here W1 means alpha, this alpha and 0 W2 and minus alpha W3. So we can write this is equal to W into W comma alpha 0 and minus alpha. This is equal to Z 0 alpha and Z2 means alpha and Z3 infinity. This. Now the cross ratio is equal to W4 minus W1 into W2 minus W3 by W4 minus W3 W2 minus W1. This is equal to Z4 minus Z1 Z2 into Z2 minus Z3 by Z4 minus Z3 and Z2 minus Z1. These two are equal. We put the values. This implies the W4 means minus alpha, so minus alpha minus W1 0, W2 means alpha minus 0 by minus alpha minus 0 into alpha minus W. This is equal to suppose this infinity, let us take this as Z dashed, so this is equal to Z dashed minus Z. Z4 means this Z1, so this is Z1, Z2, Z3, Z4. This is equal to W. From this we write Z dash minus Z 0 minus alpha to Z dash minus alpha 0 minus Z. This is equal to minus alpha is equal to minus alpha minus this is W1 means W. So W1, W4, this is W4, W1 means W, this is W. Alpha into minus alpha into alpha plus W by minus alpha into alpha minus W. This is equal to take common Z dash 1 minus Z by Z dash minus alpha by Z dash into 1 minus alpha by Z into minus of Z. Z dash cancel, and since Z dash equal to infinity, so this term goes to 0 and this term also goes to 0. So alpha minus alpha cancel. This implies alpha plus W by alpha minus W. This is equal to, we can write simply this is minus alpha by minus Z. Minus cancel. Now multiply alpha Z plus WZ. This is equal to alpha square minus alpha W. So take common W into Z plus alpha. This is equal to alpha into alpha minus Z. This. So from this we can write W equal to alpha into alpha minus z by alpha plus z, this. So this is the linear transformation equal to tz, and from this we can write z equal to alpha into alpha minus w by alpha plus w, which is equal to t inverse w. So we get two transformations, since here in the options t inverse and t, both the transformations are included, and we know that if t is a linear transformation, bilinear transformation, then t inverse is also a bilinear transformation. We get this. Now the first option is say that T maps L to a straight line, and L is what? L denotes the straight line passing through the origin with slope -1. So the equation of the straight line like this: y equal to -x, and alpha equal to, given that alpha equal to -1 by √2 plus iota by √2, this. Now if we take a point z equal to suppose 2 alpha, then this satisfies this condition also, and with the slope -1 also. Therefore we put here in this transformation, therefore t of 2 alpha, find the image of t of 2 alpha. T of 2 alpha equal to, if we put here, we get alpha into alpha minus 2 alpha by alpha plus 2 alpha. This is equal to alpha into alpha minus alpha means minus alpha by 3 alpha. So this is equal to alpha cancel, so minus alpha by 3. Yes, minus alpha by 3, and alpha is the point this, and so 3 alpha by 3 and 3 by √2 again. So if we write this is the w plane, so the point is 2 alpha means in z plane, so 2 alpha goes to, and it is given that alpha in here it is given that t of alpha equal to 0. So t of alpha equal to 0 means the value of alpha should be in 0 in the w plane, and t of 2 alpha in z plane gives minus alpha by 3, and minus alpha by 3 means what? So minus of 1 by 3 into alpha means 1 by √2 plus, sorry, minus 1 by √2, minus 1 by √2 plus iota by √2. So this is equal to 1 by 3 √2, 1 by 3 √2 minus I by 3 √2. This plus minus means fourth quadrant, so these two are equals, that means suppose here this point is, so 1 by √2, 3 √2 and minus 1 by 3 √2, this is the point suppose. Now so these two points cannot lie in a circle, so clearly this is an straight line. Also if you can take another point, then we get a point in here, so this is clearly a straight line in w plane. So the answer is, for the first case you can take another one point to check this, because of calculation is very big, so I can conclude from this point only. If you are not satisfied, then you can take another point and calculate this calculation. So this is the maps T is L to a straight line. This A option is correct, and therefore B option is incorrect. Now for next two option, here see that C denote the straight line, C denote the circle unit radius centered at origin. So C T inverse to T, C goes to T inverse to T, that means C is in, suppose C is in W plane, therefore the here T inverse goes to W plane to Z plane, and T inverse W equal to Z equal to, given that the transformation is this: alpha into alpha minus W by alpha plus W, alpha into alpha minus W by alpha plus W. This is the transformation. The value of alpha equal to minus 1 by √2 plus iota by √2, this value of alpha. Now if we take the point alpha, then from the given it is clear that since t of alpha equal to 0, then t is 0 equal to alpha, then t inverse alpha equal to 0. We get already 1 point. T inverse alpha, this is equal to 0 point. Now we take the point which is like the points alpha, since this is easy for calculation. Now let us take, so we already get t inverse alpha means 0. So suppose this is the inverse plane, that is z plane. So t inverse alpha means 0. So this is the origin. Now and the equation, and it is given that the c is suppose u square plus v square plus 1, which is unit circle passes through origin. This, therefore we take the point alpha, the point such that which satisfies this condition, and then we have to check whether whether the point goes under the transformation T inverse. So let us take an point W under the transformation, this inverse transformation T inverse W. So W equal to, let us take the point 1, W equal to minus 1 by root 2 plus iota by root 2. Now we put in this transformation, so this is equal to, suppose let us take another color, so this is equal to now T inverse W equal to Z equal to T inverse W. This is equal to alpha into, alpha means minus 1 by root 2 plus iota by root 2 minus W. W means this, so minus W means minus 1 by root 2 and sorry, minus root 2 means, oh sorry, let us first take these two are plus plus. So minus 1 by root 2 minus iota by root 2, this by alpha plus W. Alpha means minus 1 by 2 plus I by root 2 plus the omega W means 1 by root 2 plus I by root 2. So here minus plus cancel and here plus minus cancel. So this is equal to alpha into minus 2 by root 2 by, we get this 2I by I into 2 by root 2. So 2 by root 2, 2 by root 2 cancel, so minus alpha by I, we get this. So this is equal to, if we multiply both numerator and denominator by iota, then we get I alpha. So this is equal to I into alpha means minus 1 by root 2 plus iota by root 2. So this is equal to simply minus iota by root 2 minus, this is minus 1 by root 2. So minus minus means third quadrant. Suppose this, so minus minus means suppose this is the point, sorry, this is the point, this is the point, this that means the pair is minus 1 by root 2 and minus 1 by this. Now we take another point, take W equal to minus 1 by root 2 and minus iota by root 2, this. Now we calculate T inverse W, that is Z. This is equal to alpha into alpha minus W. Alpha means minus 1 by root 2 plus iota by root 2 minus W means these two both plus 1 by root 2 plus iota by root 2 by alpha plus W. Alpha means minus 1 by root 2 plus iota by root 2 and plus 1 by root 2 means these two are these two. So plus minus cancel and minus plus cancel. So this is equal to alpha into 2 iota by root 2 by minus 2 by root 2. This is equal to I alpha by minus 1 and this is equal to minus I into minus 1 by root 2 plus iota by root 2. This is equal to, we can write iota by root 2 plus 1 by root 2. This means those two are plus plus. So 1 by root 2, 1 by root 2, suppose this is the point 1 by root 2 and 1 by root 2. Joining these 3 points, we get clearly a straight line. We can conclude these two from these 2 points also. So this is also a straight line. These questions are very lengthy. So this is also, this C option is correct and D is not correct. So this is the complete solution of GATE 2022 complex analysis. So how was the video? If the video is helpful, then please give a like to this video, share with your friends and subscribe the channel. Thank you friends. See you again in the next video. Thank you.